Section 11.1 ellipses. So we're continuing on from circles. We're going to skip the warm-up part and we're just going to go down to the notes. The objective is to construct equations for ellipses and graph ellipses on a coordinate plane. The vocabulary that we have for an ellipse is a curved line forming a closed loop where the sum of the distances from 2 points, the foci, to every point on the line is a constant. So that's talking about, these are called the focal points. This right here would be the center. And the distance from here to here, so the distance from one focal point to the point on the graph to the other focal point, is always going to be an equal distance, but that's how we end up with our ellipse. So this point from here to here, and then you could keep on going. So this length for each of these is going to be a specific length. But let's go ahead and look at an animation of this to make it look a little bit easier. So what this is talking about, here are your focal points right here and here on your graph. And so notice that as the distances for the red and blue line are changing, notice that the total length of d1 plus d2 is constant, which is this number right here. So that's the definition of an ellipse. And that constant value is always going to be equal to the same length. And the same length is always the length of the major axis. So d1 plus d2 is equal to 2 times a if our major axis is horizontal, which we'll talk about. There's two types of ellipses. We have a vertical ellipse and a horizontal ellipse. The vertical ellipse would look something like this. And this would be the center. And this would be a focal point, and this would be a focal point. The one that we have to the left of this ellipse right here, this is a horizontal ellipse. So this one's called horizontal because the length of the major axis, which is this right here, is longer than the length of the minor axis, which is on the y. So because the major axis length is longer on the x, that's why it's called a horizontal ellipse. And over here, this would be the major axis because that distance is bigger than this distance. That's why it's called a vertical ellipse. So the major axis would be the one in green for the vertical ellipse, and the blue would be the minor axis. So the major axis is always the longer axis, the minor axis is always the shorter axis, and the vertices are the endpoints of the major axis. So right here and here are the vertices. So then right here and here would be a vertice. So it changes. If it's a vertical ellipse, the vertices are on the y-axis. If it's a horizontal ellipse, the vertices are on the x-axis. Now, the equation that we get for an ellipse is x squared over a squared plus y squared over b squared equals 1. This is for an ellipse with a center at 0, 0. We're going to actually skip over doing ellipses with center at 0, 0, and we're going to just kind of cut right into doing some of these problems, since some of you have done this in Algebra 2 already. Another thing that I need to talk about for an ellipse that I know that the distance from here to here is going to be a specific length, and notice that if this is A out here, then I know that this distance from here to here is going to be 2a, so the major axis length in this case is 2 times a. The minor axis, which is this way, which is a value of b, would be 2 times b. And if I want to figure out where the focal points, we are calling the distance from here to here c. Well, if you recall, the distance from one focal point to any point on the circle to the other focal point is always going to be a constant length. And if it hits right where our minor axis is, then I know that it's cutting our distances in half. So this actually is a distance of A, and this is a distance of A. So if I want to find C, how would I go about doing that? Well, then C would be equal to, using the Pythagorean theorem, this would be my right triangle. So C squared plus B squared equals A squared. So C squared is really equal to A squared minus B squared. And then we would take the square root of that. So that's how you find the foci. It's a little bit different for if we have a vertical ellipse, which we'll talk about next. So the general equation is this equation that we have right here, x minus h squared over a squared plus y minus k squared over b squared equals 1. The equation must be equal to 1. If the a value is bigger than the b value, then you have a horizontal ellipse, which means the major axis is on the x-axis. If the a value is less than the b value, then you have a vertical ellipse, which means the major axis is on the y, and your vertices would be on y. Now, it's a little bit different for the equations in your book. They switch the a and the b, but I think that's kind of confusing, so we're going to use these. The center for this is h and k. A is the distance from the center to the vertex in the x direction, which makes sense because it's over x. B is the distance from the center to the vertex in the y direction because it's over y. C is the distance from the center to the focal point, which we find by doing this down here. The vertices are the ends of each axis, but we only use it for the major axis. The foci always are on the major axis, and the major axis has a length of 2 times A, or if it's vertical, it would be 2 times B. So it depends on which way your graph is opening. Now, to find the value of C, if A is greater than B, which means we have a horizontal ellipse, then you're going to do c squared equals a squared minus b squared. If it's a vertical ellipse, then you're going to do b squared minus a squared. How do you know? Just always subtract the bigger one. Another note to point out is that for ellipses, the sign in between the two is always going to be a plus sign. So that's important because hyperbolas, which we'll do next, is going to be a minus sign. Now, the graphing procedures for an ellipse. If necessary, you might have to complete the square. The equation must equal 1. Locate and graph the center. Go A units each way in the x direction, B units each way in the y direction, then calculate, graph, and label the focal points. So let's practice. Okay, so here's my equation. The first thing I like to do is write down my a squared, which is always over your x, so 25. The b squared is 4, so a would be 5 because you take the square root of 25. B is equal to 2. And I always want to find the center. So this is my h, this is my k. So the center is going to be -4 because it's opposite, comma, 3. And that's the first thing you should graph, which would be right here. Now, in this case, I know that the a value is bigger than the b value, so I know this is going to be a horizontal ellipse. And since it's horizontal, that means that the major axis is going to be the x-axis. And that is always the case when the ellipse is a horizontal ellipse. Now, the next thing you want to do is you're going to count the distance of A and B on your graph from your center. Now, how do you know which direction you're going? A is over x, so you're going to go to the 5 to the right and 5 to the left from your center. So then that means that from the center to the right, 1, 2, 3, 4, 5 would be right here. To the left, 1, 2, 3, 4, 5 would be right here. So these are also called the vertices. So we have vertices at 1, 3, and also negative 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 9, 3. And now I need to do the b value, so I'm going to go the distance because it's over y up to, because that's our b value, and down to. So that's going to be the length of the minor axis. So 2 and 2 is 4, so the length of the minor axis is 4. And how do you get that? You can do 2 times your b, which in this case is 2 times 4, or 2 times 2, which is 4. And the length of the major axis is going to be the longer one, so 2 times a in this case, which is equal to 2 times 5, which is 10. And you can even count from the distance from here to here is 10. The distance from here to here is 4, so it's easy to tell in the graph. Now all I have to do is just connect this to make my ellipse as best as you can. So now I have my ellipse. Now I need to figure out what the focal points is going to be at by finding C. So if I want to find C, then I know that I can use the fact that C squared is equal to the larger number squared, so 25 minus the smaller number, which is 4. So C squared is equal to 21. And that means C is equal to the square root of 21. So the major axis endpoints we already wrote down, which were at negative 9, 3, and 1, 3. The minor axis endpoints were at negative 4, 1, and negative 4, 5. And you can just count on your graph. So then for the focal points, we are going to do 2 different things. Well, notice, remember we said the focal points are always on the major axis. So this is the major axis right here. So that means we're going to, from the center, we're going to go a distance of C, which is root 21. So we're going to go to the right root 21 and to the left root 21. So that means what we're doing is we're taking our x value from our center, which is negative 4, and we're adding and subtracting root 21 to that value. And our y value stays the same. So when I do this, if I do negative 4 plus root 21, negative 4 plus root 21 is 0.58. So that means I have at 0.58 my first focal point, which is right here. It's kind of hard to see. And then if I do negative 4 minus root 21, I get negative 8.58. So if I count from the center to the left to an x value negative 8.58, it'd be right in here. So that's a focal point, and this is a focal point right there. So now we have everything we need for this ellipse. So it's very important to be able to find the center of the circle, and then basically you just go from there. So now let's look at number 2 and see if we can do this one. So I would pause it and see if you can do it on your own, and then unpause it, and we'll do it together. All right, for this one, same thing. Notice that now my a value, which is 9, a squared is 9, so the a value is, in this case, 3. My b value is 25, so which means 5. So notice that a is less than b. Anytime a is less than b, that means we have a vertical ellipse, which means that the major axis is going to be the y-axis. the center is at, this is h and k still, because h is always with x and k is always with y, so the center is -1, -2, sorry, -1. So then when I plot this, I have -1, 2, -1. So that's the center. Then for the next part, I'm going to count up a distance of 5 and down a distance of 5 because that's my b is 5 and it goes with the y. So up 1, 2, 3, 4, 5, down. And then that is my major axis. So if I count that distance, my major axis is going to be 2 times 5, which is 10. My minor axis now, I'm going to go from the center to the right 3 and to the left 3, because this is over my x. So then the minor axis is going to be 2 times 3, which is 6, and you can even count that on your graph. So I can now draw my ellipse. And again, an ellipse is just an elongated circle, if I didn't say that before. So, oh, those are the endpoints. I didn't realize I wrote that in the wrong space. So this should have been 2 times 5, which is 10, and this is 2 times 3, which is 6. So I'll just erase that. So now I can write down the major axis endpoints, which would be here and here. So those major axis endpoints are at -2, 4, and -2, -6. The minor axis endpoints would be at -5, -1, and 1, -1, so you can just look at your graph. And remember that the major axis endpoints are also called the vertices. So again, this is the major axis length. We're not done because we need to find the focal points. And to do that, I take c squared equals, it's always a larger one, so in this case, b squared minus a squared. So c squared is equal to 5 minus, or 525 minus 9. And when I solve, I get this is equal to 16. So c squared is 16. That means that c is equal to 4. So that means if I go from my center, I'm going to move my graph up 1, 2, 3, 4. So this is my first focal point, and down 1, 2, 3, 4, and that's my second focal point right there. So what I did to get that is I took my center and I changed my y values this time. Notice because my major axis is on the y-axis and not the x-axis like I did the last time. So the center was at -2, -1, and then we added and subtracted my distance of c, which was 4. So that means that the foci are at -2, 3, and -2, -5. Which again are right here. So this is 1 and this is the second one. And that's everything that you need to know. So knowing the equation that you have is very important. And remember that when it's a vertical ellipse, your major axis is the y, or up and down. When it's a horizontal ellipse, your major axis is the x, or left to right. So bring this with you to class and we're going to do a bunch of practice.